Today we'll take a quick look at an example, show a slightly different method of the integration by substitution, couple little details that are slightly different than the way the course material presents the integration by substitution. So we'll just run through an example here and show a couple different things. If we have this definite integral, well, our fundamental theorem says if we can find the antiderivative of our function and then we can plug in our numbers, f of b minus f of a, well, in working with substitution here, we let u equal something, and in this case, what shall we let u equal? Okay, x squared minus 4, the inside part of something, and then du will be what? Okay, 2x dx. Now the material says we already have the x and the dx, we just need a 2 in there. Well, sometimes that can get a little confusing, so let me show you a little different way of approaching this, a little more straightforward substitution. We know we're going to let this part be u, and then we can say, okay, what is dx? Take this equation and solve it for dx, which we would be dividing both sides by 2x, and dx will be du divided by 2x. So as we substitute that in, like I said, we'd have u to the 5th. We'll leave this x by itself for now. I think you'll see what happens with it as we substitute in what we found for dx, du over 2x, and what happens as we simplify. Okay, the x's cancel out, so that and that go bye-bye, and we're left with now 1/2 times the integral of u to the 5th du. Now, notice I've changed this back to an antiderivative rather than a definite integral. This is another slight difference, another alternative way to look at it. What our material shows is we go through and find the antiderivative, okay, and then we plug it back in, we turn it back to x before we apply our integration limits, which is fine, that works. So we'd have 1/12 and then x squared minus 4 to the 6th evaluated from 0 to 2. Well, that's gets kind of long and drawn out. We sometimes can lose our integration limits. Let me show you a slightly different way where we're going to leave it in terms of u. But in doing that, even back at this point, we can look at our integration limits and think in terms of our different variables. Technically, with the dx out here, that means that we're saying here x goes from 0 to 2. Okay. So our integration limits, x equals 0 up to x equals 2. But down here, notice we didn't put, I guess even in this spot, we didn't put integration limits because we've got du now. Everything needs to turn into terms of u, okay, for this to be a definite integral. Well, we can substitute our integration limits as well. If x equals 0, u is what? Okay, -4. So I'll go ahead and put that down there, kind of ran out of room above it. So we can integrate with respect to u from u equals -4 up to what? If x is 2, u is going to be what? 0. So rather than changing this back to terms of x and then using the 0 to 2, we can keep it in terms of u and use -4 to 0. So let's go to the next page and show. I'll go ahead and show both parts and show that we get the same answer, just a little different way of using the variables. So our two different directions, we have this to then apply the fundamental theorem and plug 2 in here and then minus plugging 0 in, or in this direction, well, I didn't write the 1/12 but could, and then going from -4 to 0, we start with the 0, and I'm missing something, aren't I? That should be to the 6th power, shouldn't it?
Yeah.
Okay. So in this case, we'd have 0 to the 6th and then minus -4 to the 6th. Well, as we look at each part, what does that all simplify to? 2 squared minus 4 is 0, so we'd still have 0 to the 6th. And then minus, well, this would also simplify down to -4 to the 6th, which we have right there. Now, careful, we'll still have the negative there, but either direction we get 1/12 times, well, negative and then whatever 4 to the 6th turns out to be. Anybody know? 4,096? You think?
Sounds right.
4,096? It'd be
16 squared, 16 squared is 256, and that squared is...
okay. Well, and then we can simplify all that. Somebody with a calculator want to do that? Not that I don't trust Cole or not, but. So we end up with that as our result. But the point is, there's a couple different directions you can go. Our online material goes one direction in both of these cases. I just wanted to show you a different way. Maybe that way will be a little more understandable for you. Either way works. You get the same answer, or you should. But one method might make a little more sense to some of you, and the other method may work better for you. That's going to be your personal preference, whichever way you choose.